Let's look at a more complex example of combined simulation. In this example, coal is loaded from a main storage yard down chutes into barges at 4 docks. Coal is loaded into the barges when they are available at the docks. A tugboat tows a few barges. It takes time to set up the tugboat when it arrives. It also takes time to untie the tugboat when it leaves. The maximum speed of filling is 2,400 tons per hour. The barges have different capacities. We assume that the percentage of incoming barges are as shown in this table. We may use discrete distribution to represent them. Note that the percentage in disk should be cumulative. For example, for capacity 400, the cumulative percentage is 12 plus 3 equal to 15, recorded as 0.15. Tugboats arrive at different rates, assuming this is a non-stationary person arrival process. For results, we are interested in knowing how many tugboats are waiting and actual time to fill the barges. Coal loading is obviously a continuous process. The other processes are all discrete. The barges need to be ready for the coal to flow to them. The discrete part of the simulation is easier than the models we discussed before. What makes things complicated is the fill rate, which changes according to the number of barges being filled. The coal filling is a continuous process, so we will use levels and rates elements. There should be one level and one rate for each dock. We use 2 arrays. One array keeps the level values, the other array keeps the rate values. We use station Simon block to represent the 4 docks. They are numbered as 1, 2, 3, and 4. The model has 3 portions. The first portion has continuous levels and rates elements. Apparently, this is to model the continuous filling process. The second portion is barge arrivals. We know barges come with a schedule. The third portion is to detect whether barges are full and should leave. In the barge arrivals portion, we create empty barge entities according to its arrival schedule. Barges try to seize a dock, the resources from the set of docks. Note the action is seize delay but not release yet. The dock number of the seized dock is a safe attribute. When seizing resources in the process module, we also need to update a few variables and a rate. Barge rate is an array of 4 rates. Beginning fill time and the barge capacity are both array of 4 values. Because they are arrays, the type in the assign module is other. The detect full barges portion first uses detect block. It tries to watch out if any barge level is over the barge capacity. If it is over, the station number is recorded in an internal arena variable J. Whenever one of the barge levels passes its threshold values, an entity is created and leaves the detect module. Arena also assigns the index J to entity.station. After detecting a barge is full, we change the entity type to full barge. We also assign entity station to the dock number attribute. Remember that dock number is a safe attribute when a dock is seized by an empty barge in the process module. Since barge is filled and ready to leave, we clear its rate, level, and capacity. We also reduce the filling docks by 1. Next, we want to test if there are any barges still filling. If any is still filling, we need to change the filling rate, otherwise we don't want to change anything. Then we need to record barge fill time. Begin fill time was recorded in an earlier assignment module. After setting up the replication parameters, we may run the model. We obtained some interesting results. We may make a few plots for the resources and the number of barges waiting. In order to simplify continuous simulation, Arena has provided a new set of templates called the flow process. There are 7 modules in this template. This makes the combined simulation model more fluent. The modules with gray background are flow process templates.